Hello everyone, welcome to Mathematics Pathshala. In this video, we are going to discuss a problem on calculus of variation taken from CSIR UGC NET December 2023 of part C, and the question ID is 704098. So, among the curves connecting the points 1, 2 and 2, 8, let gamma be the curve on which an extremal of this functional given can be attained. Then which of the following points lie on the curve gamma? So here our goal is to find those points from these given options which lie on the curve gamma. So let us take these as f of x, y, y dash is equals to 1 plus x cube y dash into y dash. So here we can write it as y dash plus x cube y dash square. And to solve this kind of problems, what should we must know? We have to know the Euler-Lagrange equation. So see, what is Euler-Lagrange equation? Euler-Lagrange equation, that is ddx of del f del y dash minus del f del y is equals to 0. So here it is the function f. So doing derivative with respect to y dash, here what we get? We get ddx of 1 plus 2 into x cube y dash. And here, as no terms exist with y in this expression, so del f del y will be 0. So we can write it as ddx of 1 plus 2 into x cube y dash is equals to 0. And here we get 1 plus 2x cube y dash is equals to c, integrating both sides, where c is any arbitrary constant. From this we can derive y dash, that is y dash is equals to c minus 1 by 2 into x cube, and we can write it also as c minus 1 by 2 into x to the power minus 3. Now see, if we integrate it from both sides, then what we get? We get y is equals to, here this is constant c minus 1 by 2 into integrating, we get x to the power minus 3 plus 1 by minus 3 plus 1 plus c1, where c, c1 both are in arbitrary constants. Both are arbitrary constants. So here if we calculate this, we get y is equals to c minus 1 by 2 into minus half of, here it will be x to the power minus 2, that is we can write 1 by x square plus c1. Now here we get y is equals to this. We can denote it as 1. Now as given, we can use here the given conditions, as these 2 points 1, 2 and 2, 8 lie on this curve y. So if we put x is equals to 1 and y is equals to 2 in 1, then what we get? If we put x is equals to 1, y is equals to 2 in 1. Then we get here 2 is equals to c minus 1 by 2 into minus half plus c1, and calculating it we get 4c1 minus c minus 1. It will be 8, that is 4c1 minus c will be 7. Let us note it as equation 2. And similarly, we can put another point in 1, that is x is equals to 2, y is equals to 8. If we put this, here we get 8 is equals to c minus 1 by 2 into minus half into 1 by 4 plus c1. That will give 16c1 minus c minus 1 is equals to, here it will be 128. So we get 16c1 minus c is equals to 127, and we denoting it as 3. Now you can see simply that solving these two equations, we can easily get the value of c and c1, the arbitrary constants, and put it in this equation 1. So let's solve these two equations to get the value of arbitrary constants. Here 4c1 minus c is equals to 7 and 16c1 minus c is equals to 127. So here we will cross off and here we get minus 12c1 is equals to minus 120. So it will be c1 is equals to 10. So we get c1 is equals to 10, and if we put c1 in any of these two equations, we can get easily the value of c. So we are putting in 2. C is equals to, c1 is equals to 10. So we get here 40 minus c is equals to 7, that is we get c is equals to 33. Now if we put the value of c and c1 in this equation, we get y. So putting c is equals to 33, c1 is equals to 10 in 1. What we get? We get yx is equals to c minus 1 by 2 into minus half of 1 by x square plus 10. Sorry, here it will be 33. So finally we get 16 into minus half into 1 by x square plus 10, that is minus 8 by x square plus 10. So here we find yx. So this is actually the curve gamma as per the given problem, that is the extremal of the given functional. And now what we do? Now we will check in between the 4 options which lie upon this curve gamma. So let's check one by one the options. Our first option is given. Here first option is given root 2 and 3, and we get here we get yx is equals to minus 8 by x square plus 10. So if we put here, we get minus 8 into 1 by root over 2 whole square plus 10. So here we get it is minus 4 plus 10. It will be 6. But here y is given 3. So 6 not equal to 3. And here, so it does not satisfy. This point does not satisfy the curve. Does not satisfy. Let's check option 2. That is root 2, 6. Here you can see that when we put x is equals to root 2, then we get 6. So option 2 is already you can see is true. Now check option 3. So here we get root over 3 minus 8 into 1 by root over 3 whole square plus 10. It will be minus 8 by 3 plus 10. That is, here we get 30 minus 8, 22 by 3. So when x is equals to root 3, we get the value of y is 22 by 3. And here y is given 22 by 3. So it satisfies the solution curve. So root over 3, 22 by 3 lies on the curve gamma. And here, see this point, it is root over 3, 23 by 3. That is, when x equals to root 3, y will be 23 by 3. But we already have seen that when x is equals to root 3, then y will be 22 by 3 here. Hence, without checking, we can say that root over 3, 23 by 3, this point does not lie on the curve. But you can check it for your own clarity. So here, we find that option 2 and 3 are the points that lie on the curve gamma. Thank you for watching the video, and if you do not subscribe our channel till now, please do subscribe our channel.